Okay, so today we're going to be testing out a new thing. I've got a microphone, so hopefully you'll be able to hear me when I turn around and talk at the board. So we're going to try this out today. Today we're going to be doing section 2.6. This is we're solving absolute value inequalities. Now, this is the last section of chapter 2 before our test on Friday, and I do want to let you know one thing. Nothing that we're covering today is going to be new information for you. Everything that we've covered today, you already know. If you've kept up with chapter 1 and the rest of chapter 2, there's nothing new. And intuitively, this also is one of the ones that makes sense for a lot of students. Now, some of the math, some of the students are still struggling a little bit on how to solve the equations. That's okay. A little more practice will get that refreshed. But again, let's take a look at what we're covering. Students know that absolute value is the distance from 0. So if I want the absolute value of 2, that gives me 2 units. And if I want something that is 2 units away, I can either go in the positive direction or in the negative direction, so I'll get 2 possible answers. Today we're covering inequalities, which means I'm going, instead of I want 2 units, I want less than 2 units, which means I'm going to be covering everything between. I still need to figure out where those points are, but I'm going to cover everything between them if the absolute value is less than something. And inversely, if I'm looking at the absolute value being greater than something, I'm going to have the ends of my number line shaded. So I'm going to have numbers that are going to be on the edges of the graph. So let's take a look and see how that would appear. So with the absolute value being greater than 2, we're going to draw ourselves a number line, center it at 0, and give ourselves some numbers here, -2, -4, +2, +4. Now, I know the absolute value is going to be set at, I need it greater than 2. So what is the minimum distance that I can use here? The minimum distance is going to be at 2. 2 units away, 2 units away. I've moved 2 units away from my center point. And I want it to be greater than that. So the things that are at least 2 units away are going to be on the edges of this graph. So my graph is going to look like this. Now, we did talk about what does this graph look like? Well, we just did one yesterday. The ones we did yesterday, these are going to look a lot like our OR functions. So I told them, I'm like, let's identify a few things about this. The first thing we're going to identify is I need to know that these are my absolute value. So I have the absolute value of 2. Okay. Additionally, we know some other things. I know that all of this area over here, beyond and to infinity, or as my students wanted to say, to infinity or beyond. Don't know where we've heard that one before. They said this is all the area that is greater than. So this is the distance that is greater than 2. And you can see we have 2 different distances. If I want you to move 2 feet, at least 2 feet away from where you're currently standing, you can go that way, or you can go that way. So you've got 2 different parts of this graph, which is going to represent an OR function. We covered those yesterday. An OR function is when the absolute value is greater than. Okay? That's going to give us 2 distinct parts. So the OR function, I'm going to have the part on the left and the part on the right. Conversely, I've got when x, the absolute value is less than 2. So if I want something that is less than 2 units away, I'm going to go at max 2 and at max 2, but I want to stay between those 2 values. So again, I got to find the 2 values at 2. Let's go ahead and set that up. Don't know what I was drawing there. Set it up at 0, -2, -4, 2, 4. Now again, the absolute value is going to be anchored at these points of 2, but I want it to be less than 2. So I'm going to only go like maybe 1, 1.5, 1.7, 1.9. I'm going to go anywhere within this range, but I'm not actually going to make it all the way to the 2. So what we've got going on right here is I have this space, which is the distance that is less than 2. And we know it's less than 2 because I have these 2 points right there, and these are going to be the absolute values of 2 again. Okay. So when I have the absolute value of 2, I'm looking at a distance of 2, but I want it less than that, so in between those 2 extreme points. Now this looks like what we did yesterday. Again, unlike the OR function, when we went between 2 things, that looks a lot like an AND function. So an AND function is how we evaluate absolute values that are less than. Okay. So we've identified everything that we're going to do today is based off of these 2 concepts. We asked the students, I asked them several times, I was like, hey, do we get the idea? Overwhelmingly, yeah. A lot of the students get that. If I'm looking at a distance greater than, I move to the edges. If I'm looking at a distance less than, I'm staying bounded between. So we had a between and a beyond. So let's cover a few examples to make sure we get the idea of what does that look like in practice. Okay, so numbers 3 and 4. Number 3 is the absolute value of x plus 7 is less than or equal to 2. Number 4 is going to be the absolute value of 8x minus 11 is less than 0. Okay. So just like what we had right here, I have a distance that's going to be less than 2. So whatever's going on over here, I know that my distance has to be no more than 2 units to the left and no more than 2 units to the right. So it's going to be within about a 4-unit span in here. Considering 2 to the left and 2 to the right, it's going to be within 4 units. That within, I know, is going to give me an AND function. So let's go ahead and let's solve it. Now, if they don't remember, this was from section 1.4, how to solve an absolute value. The 1.4 things, we said, hey, locate the absolute value brackets, isolate them, make sure that the only thing on that side of the equation in 1.4, the inequality in this section, and then duplicate it. So I'm going to go ahead and I'm going to write this down twice. I'm going to say x plus 7 less than or equal to 2, x plus 7 less than or equal to 2. And when I do that, I can get rid of the brackets as long as I remember that there are 2 directions that I'm considering, a left direction and a right direction. So I have a negative and I have a positive. And then basically I just solve the inequalities just like we've been doing all chapter. So with the inequalities, I'm going to say, okay, distribute that negative. That's going to make that a negative x minus 7 less than or equal to 2. Okay. First thing I get rid of is I add the 7, add the 7. I'm going to have negative x is less than or equal to 9. And then here's one of the things I did ask them. What's the number that's invisible in front of the x? And it is a 1. Pretty much everybody was like, oh, well then, yeah, I know to divide there. So I get x, pause. What happens when I divide by a negative? Well, the inequality says I flip the sign. So I get x is greater than or equal to negative 9. So remember, this is going to be bounded. So what I've got going on here is I know it's going to be greater than or equal to negative 9. And how far did we say that gap was supposed to be? Well, 2 units in each direction. So if I'm going to the left, negative 9, 2 units, 2 units, I should find my right barrier over here. So from negative 9, I should get something like a negative 5 for my next answer. Let's see. So if I work this one, again, I'm just going to draw my line down. I'm going to distribute a plus sign, which does nothing. Okay? So I'm going to get an x plus 7 is less than or equal to 2. First step I do is I subtract the 7, and that will give me an x is less than or equal to negative 5, exactly like we predicted, because that is 4 units away from that one. because remember, I'm moving 2 and then 2. So we graphed these yesterday when we graphed compound inequalities. So I'm just going to do that. Graph this, I know it's an and, I know I'm going to be between those two barriers. So 1, 2, 3. I have my x is greater than or equal to -9. I have my x is less than or equal to -5. And then this is going to be my and or my final answer. My -9 is on the left. I have my -5 on the right. Okay. I need x is greater than or equal to -9. So I'm going to circle my -9, and the greater values are off on the right direction. So I'm going to shade over here. And do I include the 9? Yes, because it's or equal to, so that's shaded in. For the less than or equal to -5, I'm going to find my -5 and shade the lesser direction, which is to the left. And then I'm also going to shade in the -5 because it's or equal to. And now remember, I'm looking at something that is between those two values. So I can already see it's where they're going to overlap. So even if I didn't remember which one, I'm like, oh, it's between the values. That's going to be like an and function. So I'm going to say, hey, it's between this one and this one. They both have the value of -9. They both have the value of -5. And so that is going to be my final graph for the absolute value of x plus 7 is less than 2. Okay. Now, just like this one makes intuitive sense as to we can figure it out and we can just see how the math plays out, this one is going to present us a problem. Because if I want to go less than 2 feet away, here I want to go less than 0 feet away. So I want you to move 0 feet to the left and 0 feet to the right. But do less than that. What's the best you can do? Move 0 feet, which would mean that you're not moving. I want you to move less than that. Are you going to be able to do it? No. So there's going to be a problem in here. Let's see if we can spot it. Okay. Locate the absolute value brackets. Isolate them. Done. Duplicate. When you duplicate, those absolute value brackets disappear because we're accounting for the left and right direction. So I have 8x minus 11 equals 0. 8x minus 11 is less than 0. So I can get rid of the brackets by accounting for the left and the right direction. Okay, let's solve it. When I distribute that negative, big thing that students are still asking, I'm distributing a negative. Everything in there gets negated. So that positive 8 is negated to a negative 8. That negative 11 is negated. So what is a negative negative? A positive. I don't leave it negative. A lot of students have been asking that question. I don't leave it negative. I am negating it, which means I'm changing it to the opposite. So this becomes a negative 8x plus 11 is less than 0. Okay. 2 steps to solve. I subtract my 11, and I get negative 8x is less than negative 11. Then I divide by the negative 8. And remember, when we divide by a negative, it's going to change the direction of that sign. So I get x is greater than 11/8. Well, it's a fraction, but okay. Now, we can check ourselves and make sure we understand what's about to happen here. I am moving 0 units away because I'm staying within it less than 0 of that one. So I bet you the next one's going to be that same number. Let's see if we can't get that. So when I distribute the positive, nothing changes. Remember, when I distribute the negative, I'm multiplying by a negative 1. When I multiply by a positive 1, nothing happens because 1 times 8 is 8. 1 times negative 11 is negative 11. I don't make that a plus sign. That was a big thing that students were still trying to do. Remember, positive times a negative is a negative. So I'm going to get an 8x minus 11 is less than 0. 2 steps and I've got this. I'm going to add an 11 here. That'll give me an 8. 8x is less than 11. Divide both sides by 8. That'll give me an x is less than 11/8. Boom. We got the exact same thing as we did over here, but this was greater than and this was less than. So again, we're seeing that we're running into a problem here conceptually. If you don't remember, let's go ahead and do the triple number line here. We're going to do an x is greater than 11/8, and I'm going to do an x is less than 11/8, and even if I don't remember, it's between, and I remember the between is an and function. Now, the 11/8 is roughly, let's see, it's 1 3/8, so that's like 0.3 something, so we're looking at roughly like 1.3-ish. This is 1.3-ish. So because it's not a whole number, I'm going to go ahead, I'm going to put it between 1 and 2. These aren't the two boundaries. This is just between the 1 and the 2. And that's the only point I have on my graph is that 1. Or that one point between the 1 and 2. So if I go ahead and I circle my point and I say x is greater than that, I'm going to shade to the right. This one I circle the exact same point, but it's less than, so I shade to the left. And then I say, okay, what's between those 2 points? Because I'm trying to get between them, but it doesn't look like there's a whole lot of space on the right side and left side. So what do they share? What are the points that are between them? Well, they don't share anything on the left. They don't share anything on the right. A lot of students mentioned, hey, that point in the middle. But do they? Is it filled in? Do they include that point over here? No. So do they even have that? No. They share nothing. And so that means that graphically, empty set. I was very excited because pretty much every class immediately, once they saw this, they were like, oh, empty set, I know how that works. And let's make sure, again, let's go back to the beginning and do we understand why? I want you to exist. I want you to move within an area that is less than 0. Okay? That means best case scenario is you can move 0, which is too big. You have to move negative distance. And can an absolute value ever be negative? No. So even though this doesn't say an absolute value is a negative, it implies that the only answers will be negative. Can an absolute value ever be negative? No. But the only things less than 0 are negatives, which is why nothing works. So that was a wee bit tricky. It wasn't too terribly bad, but I think at this point they kind of got it. Now, both of these were less thans. What we're going to look at next is I'm going to look at a greater than. So I'm looking at the outside and I'm looking at OR functions. Let's go ahead and clear off this side and let's do a couple OR functions. Okay. Let's do 2 of these. Number 5 is the absolute value of c minus 1 greater than or equal to 5. Number 6 is the absolute value of 10 minus m greater than or equal to -2. And then we'll cover number 7 here in a minute. Actually, let me go ahead and write that up here as well. I think you guys got it. The last one, number 7, is absolute value times 4 of 2x minus 3 plus 1 is greater than 17. Okay. So again, conceptually, let's make sure we understand what's about to happen here. I have an absolute value that is going to be greater than 5, which means I'm going to say, okay, I need to move 5 units this way or 5 units that way. Once I get to those 5 units, I need a distance that's greater than them, so I'm going to be moving to the outside. So I'm going to look for a graph that starts here and starts here, but moves outward. So this is going to look like an OR function from yesterday. But let's go ahead and solve it. Now we know that with an absolute value, locate, isolate, duplicate. The duplication is when I get rid of the absolute value brackets. Because I'm accounting for at this point, well, I could go left for an absolute value and I could go right for an absolute value. Let's solve it. Now again, I'm distributing a -1 here. So when I say, hey, -1 times c, that makes it a -c, and a -1 times a -1 makes a +1. This was confusing for a lot of students in a lot of classes. Again, let's go back to those basic multiplication skills. A negative times a negative is a positive, and when we distribute, everything inside gets multiplied by the thing on the outside. I think that was holding up a lot of students, but let's go ahead and finish this. First step to solve it is I get rid of the 1 by subtracting 1 from both sides. So I have negative c is greater than or equal to 4. And then I recognize that there is an invisible 1 sitting out there that I have to divide by. So I get c, pause, dividing by negative, flip, flip, gives me a negative 4. So I have c is less than negative 4. Now remember, this is, I want the distance to be greater than 5 units away. So if I'm looking at less than negative 4, okay, I'm looking at, here's my negative 4, I'm looking at less than negative 4. Okay, if that was 5 units away, 5 units, 5 units, I bet you I'm going to be at 6. Because negative 4, add 5 becomes a 1, 1 plus 5 becomes a 6. I bet you it's going to be greater than 6 values. Don't know how it's going to work out, but I bet you that's how it's going to solve. Let's try it. So, draw my line down the middle. When I distribute the positive, nothing changes. A positive times anything is just whatever it was originally. Positive, 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 negative, negative. Nothing changes. This one's easier. It's one step and I'm done. So I get c is greater than or equal to, you guessed it, positive 6. Exactly like what we were expecting. Once we understand the concept, this is really not bad at all. Okay? So let's draw my 3 number lines. I have a c is less than or equal to negative 4. I have a c is greater than or equal to 6. And I know this is going to end up being an OR function. But even if I don't remember, I'll see it pop up here in a minute, and then I will. So my negative 4 and my positive 6. I have less than or equal to negative 4, so I'm going to circle my negative 4, shade the lesser, and fill it in. Greater than 6, circle my 6, shade to the greater, and fill it in. And because I'm looking at either one of those, because again, I want the value to be greater than, which gives me 2 possible options, I know I'm going to treat it like an OR, which means anything that's in either one of those graphs, I'm going to make part of my final graph. So the left was part of the top, and the right was part of the bottom, and that's going to be my final graph for this inequality. Perfect. Now, another thing that I was pointing out at this point, they've seen a couple. We remember where the numbers were. What's directly between negative 4 and 6? Remember, I'm going 5 units in each direction. So if I come 5 units in and 5 units in, I should find a number right here that's directly between them. What number is that? 1. Look at the problem and see if you can't spot a 1 in there. Can you spot a 1? Negative 1 became a positive 1. I bet you we're going to see a trick in a later section that's going to help us work with that. Number 6, again with this one, I'm looking at a distance that is greater than negative 2. Okay, so I want you to move negative 2 units to the left. Okay, I want to move beyond that, so I'm looking in this direction. Okay, and I want you to move negative 2 units to the right, and I want to move beyond that. So what I'm looking at is I'm looking at beyond my negative distance and beyond my negative distance. I'm overlapping and confused. How do I fix that? I don't know. Let's take a peek. Some of you might have already figured out, like, oh, this one's a special case as well. Locate, isolate, duplicate. So what I'm going to do is I'm going to take this and I'm going to duplicate my 10 minus m is greater than or equal to negative 2. 10 minus m is greater than or equal to negative 2. I can only get rid of the brackets after I've accounted for I could move left or I could move right. Now I don't need to worry about them because there's 2 in there. I'm going to go ahead and I'm going to work this equation. Sorry, I got marker in my eye. Distribute that negative. Now when I distribute the negative, negative times 10 becomes negative 10. Negative times negative m becomes positive m. Again, this was still tripping students up
Just go back to your basic multiplication facts. A negative times a negative is a positive. A positive times a positive, sorry, that was completely wrong there. A negative times a positive is negative. Two positives or two negatives make a positive. If they're the same when you multiply, they become positive. If they're different, they're different. So negative, positive, negative, 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 positive. Okay. So let's go ahead and let's add 10. That gives me an m is greater than or equal to 8. My next one, as I work through this, I'm going to say, okay, multiply by a positive, which does nothing. Remember, positive, positive is positive, positive, negative is negative. Nothing changes. 2 steps and I'm done. I'm going to subtract my 10. I'll get negative m is greater than or equal to negative 12. I'm going to recognize that there's a negative 1 in front of the m and divide. And when I divide by a negative, it flips the sign. So I have m is less than 12 or m is greater than 8. We see the problem? Yeah. So if I have my m is greater than or equal to 8 and my m is less than or equal to 12, and I know this is going to be an OR function, let's set it up and see if we can spot what's going on. So I have my 8 and my 12. M is greater than or equal to 8. So I'm going to take my 8 and shade in the greater direction, which is over here, and then fill it in. M is less than or equal to 12, so I'm going to circle the 12 and shade in the lesser direction, which is over here. And again, remember how our arms crossed? I moved 2 units negatively to my left, but I'm going beyond it, so I'm still looking in that direction. I'm moving negative 2 units to my right. Okay, so I'm moving farther this way, but I'm still looking beyond it that way. So you see how my lines overlap? That's exactly what's going on. I'm starting from over here, but I'm overlapping. And so when I look at where does at least one of these exist, well, everywhere. The bottom one is over here on the left, they're both in the middle, and the top one's over here on the right. So is there anywhere that you can't pick? No, everything works. So this is infinite solutions. Or if you want to be really crazy or really lazy, you can just put all real numbers, which means anything you do works. What? Does that make sense? Okay. I want the distance to be greater than negative 2. Worst case scenario, you don't do anything and you stay put. How far did you move? 0. Is 0 greater than negative 2? Yes. Worst case scenario, you've already beaten this, which means no matter what you do, you're already good. I want every single one of you on Friday to make a score on the test that is above a negative 50. Even if you're absent, worst you can make is a 0. Is it above a negative 50? Yes. Everybody's good. That's all that this is saying. Cool. And the last one, this one just has an extra isolate step. Remember, solving an absolute value equation, locate it, isolate it, make sure it's the only thing on that side of the equation or inequality, and then duplicate it. Okay? So, big thing that students wanted to do, can I multiply that 4 in there yet? No. I duplicate before I can work with anything. I want to isolate all of this stuff. I don't want to put anything in there. Can I take that negative 3 and add the 1 and make that a negative 2? No. I want to get rid of the 1. I want to get rid of the 4 before I do anything inside of those brackets. So what I want you to try is I want you to take a moment on this one. If you can, pause the video. Try it, unpause it, and see how well you did. Because this is the epitome of pretty much everything we've done in this chapter. So give it a shot. See how well you do. Okay? Now you've probably had a chance to try it out. Let's do it together. So again, I'm not touching anything inside those brackets. So the first thing I'm going to do is subtract my 1. And I have 4, leaving the brackets alone, not touching them. I have 16. Now again, I'm not going to distribute in there, but I know the 4 really, really, really wants to be distributed, which means multiplication. So I can get rid of it, because what is the opposite of multiplication? division. So that'll leave me with the absolute value of 2x minus 3 is greater than 4. Now that the absolute value brackets are isolated, duplicate. The duplicate allows me to say 2x minus 3 is greater than 4. 2x minus 3 is greater than 4. Because I'm accounting for moving in the left direction or moving in the right direction, I can ignore the absolute value brackets at this time and only at this time. This is the only time they disappear. Let's solve both of these. Distribute the negative. Negative 2x plus 3 is greater than 4. Subtract the 3, and I get negative 2x is greater than 1. Divide by the negative 2, and I get x is, dividing by negative, less than negative 1 half. Okay. Now here's a slight little trick. I know that the distance has to be greater than 4. So theoretically what you're going to want to do, if it's less than that, I know I've found my rightward position. Move 4 units back, that would be at, negative 1 half. If I move, x is less than negative 1 half. If I move 4 units back this way, it should be at negative 5 and a half. I can't count. 4 units back would be at negative 4 and a half. 4 units back from that would be negative 8 and a half. That's what we should expect. But this one has something different sitting in front of the x that none of them did. So like this m had a 1, the c had a 1. Both the examples from the first two had 1s in there. This one doesn't. So let's see what ends up with this guy. Distribute the positive, nothing changes. Positive times anything is anything. So nothing happens, so I'm going to add my 3, which gives me 2x is greater than 7. Divide by 2. I get x is greater than 7 halves. And I'm like, pause. That's definitely not, what did we say it was? 8 and a half? Or negative 8 and a half? It's a positive number there. So let's take a look. I have x is less than negative 1 half. I have x is greater than 7 halves. And I'm looking at an OR function. Now that is between two numbers. So I'm going to go ahead and I'm going to say that's negative 0.5. And this is between 6 halves, which is 3, and 8 halves, which is 4. That's roughly 3.5. Okay. So between 0 and negative 1, this one's going to be over here. Less than negative 1 half. So my lesser direction. It's not or equal to, so I'm not going to shade it in. That is between 3 and 4. So 1, 2, 3, and 4, 3 and 4, 3 and 4. Okay. Which means if x is greater than that, I'm going to circle that point and say, hey, shade on the greater side. Okay. Neither of those are filled in, so when I look at my OR function, I'm saying, hey, as long as I'm either beneath this value or above this value, that's perfectly fine because that will keep my distance greater than 4 from the center. So at that point, let's go ahead. I'm going to write down the homework real quick. Okay, so tonight's homework is going to be page 89, numbers 1 through 16 odd. So homework from 2-6 is page 89, numbers 1 through 16 odd. That means that is 8 problems. And this is going to be due tomorrow. So this is due Thursday, 9/25. Okay. So again, that's going to be due tomorrow. Tomorrow we're going to take a day to review, go over all the stuff, and then the test will be on Friday. Now, if you have extended time, we are going to be talking to the accommodations instructor to see if we want to go ahead and start the extended time tomorrow. Give you that first day to take the test, and then on Friday you can go ahead and finish it out. That way we don't have the entire weekend gap between it. But we'll see how that goes because Some of you might want the weekend gap, some of you might not want the weekend gap, but we got to work with that. Other than that, that's it for 2.6. Hope chapter 2 was good. We'll move on to chapter 3 next.